Okay, hello all you crazy people out there. My name is Michael, I like wizards and dragons and making games, and let's talk about shaders. So earlier today, I made a video about using functions in shaders, and how you can use those to organize your code a little bit by defining and declaring a function and calling it wherever, instead of having to duplicate code. They're pretty nice. I'm going to talk about something similar in this video, and that is the use of macros in shaders. Macros are something you may have heard of in GML. If you have a constant value that you want to use, you can define a macro. You can say something like macro max slices of pizza or something, and you can set that to like, what's a standard number of slices on a pizza? 8, I think. You quarter it and then cut those quarters in half. You can define a macro, and this is going to be treated as a constant value. So you can treat this as a macro anywhere in the game where the GameMaker interpreter and or Yo-Yo compiler preprocessor sees the simple max slices of pizza. It will copy and paste in the value 8. And if you want, this can contain complex expressions such as 4 plus 2 times 2, as long as it's a something resembling valid code and can be copied and pasted into the code by the preprocessor. I made a video on macros in GameMaker a long time ago, about a year ago. If you want to see more about that, I will have a link to that video on screen and etc, etc. So you can do something similar in shaders. In fact, you can do a little bit more with them than that in shaders. First, I'm just going to run this. This is the same test project saved with a different name as the what I had in the last video about shader functions, and all it really does is it runs a color inversion function on the output color generated by the otherwise default pass-through fragment shader. So it's the vertex color multiplied by the texture 2D lookup. And then it just turns it upside down on its head and inverts the color. Red becomes blue and black becomes white and all that. I'm going to come back to this. I'm going to leave this in the code, but I'm not going to use it immediately. First, I'm going to say something like, let's do something very basic with this color. Let's set the green channel to a value. Let's just make that 0.5. Green for every pixel in the duck that's drawn is going to be 0.5. The duck is primarily yellow. Yellow is composed of red and green in color theory when it comes to light and additive colors. So we're going to be reducing the green of most of the pixels in the duck by a little bit by hard coding that to 0.5. And this is going to make the duck look orange. Cool, good to know. This is going to make the duck look orange. It's a little bit more red. There's less yellow, less green, and more red in this duck. That's fine. It doesn't look too bad. I was just hoping to steer clear of something like magenta, and I would have been happy. What's magenta? Red and I think blue. Who cares? I don't want to find out that badly. So this 0.5 here is a bit of a magic number. You may consider it bad practice to have too many things like this floating around in your code. I certainly try to avoid it if possible. One thing you can do to get rid of them, to get rid of magic hard-coded numbers like this, is save them to a variable. You can create a variable called something like float green value and set that to 0.5, and then you can assign a green value to the green channel in the color, and this is better. This is going to accomplish the same thing. The thinking goes that if you use this value in more than one place, if everything was hard coded to 0.5 or something like that, color dot red is going to be 0.5, and then maybe further down, color dot blue is 0.5. If you had multiple uses of this value elsewhere in your code and you wanted to change it later, seeking them all out and changing them to like 0.75, for example, would be a bit of a chore, and it's much easier to it's much easier to have a single value that you need to change in your code if you want to. This is going to be like a mostly lightish gray, right? All right, cool. I know how colors work. Just kidding. Sometimes I get it completely wrong. So that's something you can do. Another thing you can do in shaders that you actually can't do in GML is have a constant value. Constants cannot be changed. GameMaker does not actually have constants, it just has macros. So you can define, for example, outside the main function, you can define const float green underscore value is 0.5. It's not really the green value anymore, is it? Because it's being used for all of the color channels. Whatever. I can have misleading variable names, but I can't have magic numbers in my code. And this accomplishes the same thing. The difference between having it in the form of a regular variable and then a constant variable is obviously constants can't be changed. It's kind of in the name. It's kind of you'd expect that going into it, but constants can't be changed. If you try to change a constant, the shader compiler will yell at you because you are not allowed to assign something to a constant variable that has already had a value set to it, like this. You can do that to prevent yourself from making mistakes and accidentally changing a value when you don't mean to. You can mark something as constant if you want to not be able to change it. What you can also do is instead of defining a variable that is a constant containing this value, is you can use a macro. And like I said at the beginning, macros and shaders are somewhat like they are in GML. You can actually do a couple extra things with them. You do not use the hash macro piece of syntax to define such things in shaders the way you do in GML. Instead, you would do something more like the C languages and say define green value. And much like other macros, you don't assign a value to it, and you don't need a semicolon at the end, and you simply have a symbol that you're defining and something that is going to be macroed in by the compiler's preprocessor when you go to run the game. So everywhere that the shader compiler sees the symbol green value, it's just going to literally copy and paste in this. So the computer sees this, but you as the programmer see this, and there's only one value. And if you want to do something like modify this value, you only have to edit one line of code instead of multiple. So if we run the game again, we are again going to have a medium lightish gray in place of our duckling. That's fine. Okay. Of course, since this is literally a copy and paste job by the compiler's preprocessor stage, you can do some interesting things with this. You can, instead of having a single value here, you can have a vector. I'm going to define a vector 3 that's just 0.5. Again, no equal signs, no semicolon or anything like that. And instead of setting the red, green, and blue individually, I am going to say red, green, blue is going to equal green value, followed by a semicolon. Also, as it is tradition, it is kind of a common practice, a common standard, but not strictly enforced, to give macro constant define symbols capital letters, like this, instead of lowercase or snake case or camel case or anything like that. I like to call it a screaming case because it's capital letters. On the internet, capital letters mean screaming. So this is screaming case. It's a little bit more adamant that this is a macro value that can't be changed or something like that.
Hey.
Anyway, now I'll run the game, and this is going to work. We have our gray duckling, and you can imagine what's happening here. This value here is literally being copied, pasted in, macroed in to wherever the compiler's preprocessor sees green underscore value in screaming capital letters. And of course, you can be more creative about this. Let's make up a number. Actually, you know what? Let's actually get a nice color. Let's find a nice color. This is a nice color. That is 0080FF in hex. In shader color language codes, where color values range from 0 to 1 instead of 0 to 255, that's going to be 0, I believe 0.5, and 1 instead. And that should be a kind of nice blue, a nice light-ish blue. With our duck. Yeah, that looks nice. That's better than like magenta or screaming orange or whatever I called it earlier. Okay. So again, you can use these fairly liberally. What you can also do is you can have expressions in here the same way that you can in GML macros. I'm going to leave that alone, but instead of saying 0.50, I'm going to say 128.0 divided by 255.0. And the blue color was 255, so I'm just going to pass that value in literally, divided by 255 to normalize it between 0 and 1. And we're going to have the same thing. All right, cool. we can have expressions in these macros. If you wanted to, you can make this an even more complicated expression if you wanted. So just to show you what it's going to look like if I invert, I'm going to call the invert color function on this macro. This is going to be the inverted color. This is instead going to be expecting a vector 4 and it's getting a vector 3. All right, yeah, that makes sense because I'm only giving it a vector 3 and it expects a vector 4. Let's just change this real quick so that it expects a vector 3 and basically ignores alpha. And I'm going to need to copy this definition up here so that the function is defined to use vector 3s instead of vector 4s, because we only really care about the red, green, blue here. All right, so now we have an orange, because that is the opposite of the light sky blue sort of color that I had before. Orange and blue. All right, nice New York Mets colors. So again, since this is just a copy paste job, you can have a compound expression. You can have a more complicated expression in here as the macro value. Let's call it invert color on this vector 3 and see what happens. And I'm sure you're all smart. If you're interested in shader programming, you're pretty smart. You can see where this is going before I actually run the game. But there we have it. We are orange again. This brings me to something else that you can do with shader macros. So in GML, you can have a macro be a value or an expression, but you can't have a macro be a function. You can't say macro add A and B, and you can't make a macro expression for this to add A and B or anything of that nature. This is not allowed. The GameMaker will not let you build your game if you try to do this because it doesn't really know what to do with it. Oh no, it does. Okay. However, if you were to try to use this, it would not know what to do with it. So if you try to show debug message add 5 plus now 5 and 3 and print that out in the console in the draw event, this would not work. It thinks add is a function that it's supposed to resolve, and it doesn't know how to do that, and everything kind of goes to pieces. So GameMaker doesn't let you have macro functions. However, in some languages, in the C languages and a lot of other languages that let you do macro definitions like this, you are allowed to do that. You can have a macro acting as a function instead, and the preprocessor will be smart enough to figure out what to do with it. Try not to do too much with these. Try not to abuse them. It works best in situations where you have a very simple function that can be resolved in just 1 or 2 lines of code. So what you can do, if you wanted to turn the invert color function into a macro function, is you could say define invert color. Again, I'm going to make that like screaming case, capital letters, and using underscores between words because that's kind of the tradition standard for macros in computer science. And it's going to take a color, and there are going to be no curly braces or anything like that, but I will say the value that this macro represents is going to be a vector 3, 1.0 minus color.red, 1.0 minus color.blue. Did I miss the key, the R on it? And 1.0 minus color.green. Red, green, blue. This is backwards again. I think I did that in the last video too. Red, green, blue. Okay. So this is what the macro represents. You'll notice that if you try and actually, instead of calling the parameter to this macro function color, I'm going to call it C instead. 1, to make this a little bit shorter, and 2, you see this is what the macro function represents, but the eagle-eyed observers among you may notice that if you were to simply copy and paste this expression into somewhere in the code, this probably isn't going to work because C is not a variable or anything that has been defined at any point. In this code, C does not exist. There are no color values named C or no like varyings or uniforms or anything named C or anything like that. But if you were to call the invert color macro on, let's go with the original color, because that looks a little more interesting than inverting the solid blue. If you were to call this macro function on something that already exists, it is going to work. And that is because the shader preprocessor is pretty smart, and it knows that this is a macro function, and it knows that this is an expression that's supposed to be evaluated based on this parameter instead of literally copied and pasted into the code verbatim, the way that single values are, constant values are. That's pretty cool. So admittedly, this isn't something that you often see in computer programming very much anymore in the year 2021 or whatever the current year is. Typically, this is considered kind of messy. Makes your code kind of hard to read if you have too many of these. If you have too much macro magic happening in your code, it makes it kind of hard to read. You'll see this kind of thing sometimes in things like physics engines or rendering engines where every nanosecond counts. If an operation takes 1 nanosecond to execute and you do it 100,000 times in your code, in, for example, every frame of the game or in every step event, that's suddenly 0.1 milliseconds, which is a not insignificant portion of your frame time if you want to maintain 60 frames per second. But I digress. So, there are more things you can do with this still. So not only can you define macro values in shader languages, but much like you can in C and C++ and etc. so on down the line, you can actually check to see if something has already been defined. You can say # if def green value, and then you can put some code in here. And anything after this will only be processed by the shader compiler, not the game itself when it's running, but by the shader compiler when it compiles. If the macro green value has already been defined. If you want to do the opposite, if you want to only do something if green _ value has not been defined, you can say if ndef, and that will be if not defined. The shader compiler will only pay attention to what comes after if the symbol has not been defined. And there is, of course, else, and this is essentially the else branch of this conditional statement. And once you're done, end if. I don't want to spend too much time on this because it's not something that people really use often, but it is a cool thing you can do because the shader preprocessor is actually kind of smart, and I want the world to know about this. You can also undefine something. So this exists. I'm just going to comment that out so that it's still in the code whenever I put it on GitHub, just as a reminder that it exists and that it's there. You can also undefine a macro. So if you want to get rid of this, you could say undef. You could say undef green value, and that will undefine this macro. If you wanted to undefine invert color, you can do that instead. And now, suddenly, when we try to run the game, we are back to invert color being a thing that doesn't exist down here in the main function when we try to use it. And the compiler will complain that we're not allowed to do that. So if you want to undefine something, you can do that. In a lot of ways, the preprocessor directives that you can use here in shaders and in other languages is kind of its own scripting language in a lot of ways. Okay. So these are things that you see sometimes in header files in like C++ and whatnot, if you want a header file to only be processed once. Again, it's not something that you commonly see in shaders, but there is one specific thing that could potentially come in handy for a few people in GLSL ES specifically, when you're writing shaders in GameMaker. And that has to do with the fact that these shaders that you write in GLSL ES as your shader language are transpiled, are converted into either GLSL or HLSL 11. If you're building your game for either Windows, the Xbox, or the Windows Phone, if anybody actually on the face of the earth actually uses those, your GLSL ES code will be transpiled into HLSL 11 for use with DirectX as its graphics API. And if you're doing pretty much anything else, if you run your game on an Apple product or on Linux or on an Android phone or on most other things, your shader code will instead be translated into GLSL without the ES, which for what it's worth is very similar and is generally mutually intelligible with GLSL ES, but that's not relevant right now. Anyway, in the event that either you're doing something funny in your shaders and it produces a slightly different result on a different target platform, or you're trying to do something that may not actually work on a certain target platform, you may wish to have your code behave differently depending on whether or not you're making your game for Linux or you're making your game for Windows or whatever. Occasionally, people run into graphical bugs when they're working with one specific device. That doesn't happen on all the other things that they're making their game on. And sometimes it would be handy to know what actually you're running your game on in your shaders. And I can never remember what the actual constants are off the top of my head. Off the top of my head, I only have one head. So let me go and grab a reference to this real quick. Here we go. So these here, YY underscore GLSL ES underscore, or any of the other things in this table, these are macros which may be defined based on your target platform, based on what shader language you're actually using. So for example, I am running this on Windows, and therefore the YY underscore HLSL 11 underscore macro will be defined. I can have the shader behave differently on Windows than it would on other target platforms, without having to write multiple copies of the shader, just by using these built-in shader macros that GameMaker will provide when it compiles the shaders. So I can say, for example, let's go back to, let's use the green value macro. I will, instead of, oops, where was I? Let's just set the color.rgb equal to green underscore value. And generally that's just going to look like, well, it's not going to be green. It's going to be orange, because I don't know what colors are, apparently. I still have this named green because that's what it was at the beginning of the video, even though it hasn't been green in quite a while. So I can say if def underscore YY underscore HLSL 11 underscore, we can define green value as this, and then end if. And again, this is going to be, this is basically an if statement, which is taking the form of if it looks like this, if you were to read it out in English. This if statement, of course, has no meaning to the preprocessor, so that's not going to be useful to us. But we can define green underscore value as this thing here on Windows, and then we can also say pound else. There's also elif, by the way, which would be the equivalent of else if, and then you could have some other condition here. But for now, I'm just going to say else define. And I'm going to run this game on a Raspberry Pi in a moment. So when I do that, the value of this macro will be the blue color without the inversion going on. Okay, so first let's run it on Windows. And we have our orange duck as expected, because on Windows, on the HLSL 11 target, we are inverting this color that we are creating here. And if you'll give me a moment to set up my Raspberry Pi. Is it on? It's actually on already. That helps. All right, let me just okay, the thing didn't want to turn on the first couple tries, which was a little bit scary. Anyway, let me run this. Once it runs on the Raspberry Pi, you will see that the sprite is indeed blue, as opposed to the orange that it was on Windows. Just because of let's see, let me close out of this. Just because of the difference in the definition, the macro definition, telling the shader telling the shader compiler which version of the shader we are supposed to be running, whether this is running in HLSL ultimately, or whether it's running in GLSL on something like a Raspberry Pi or an Apple device. You may notice that in addition to GLSL ES, GLSL, and HLSL, there is a fourth option, which is PSSL. This is the PlayStation shader language in the event that you find yourself using this. I have never used this, so I could not tell you much about it. Not that I could anyway, because that console development stuff tends to fall under non-disclosure agreement, and that you are not allowed to talk to people about it outside of the PlayStation development ecosystem. Anyway, let's see. Other than that, that's pretty much it. That's pretty much it for macros and shaders. The usual warnings when it comes to using such macro definitions applies. If you have something like 5 plus 3 in a macro definition or something like that, always wrap it in parentheses if there's more than one term in the macro definition, because the way priority works, the way operator precedence works, may mean that things like 5 plus 3 ends up behaving differently in your code than you expect it to, because like if you had 5 plus 3 as your macro definition, and you did something with it, something like macro, like, times 4 or whatever. This would behave differently than you think if you thought you were going to get 8 as the result of 5 plus 3 times 4 and end up with 32 in here as the result. You would be mistaken, because what the computer would see would be this, and order of operations tells us that 3 times 4 gets evaluated first. This turns into 12, plus 5 is 17 instead of 34. If we were doing this in GameMaker land up here, I would run that code and show it happening in either the console or drawing the result on the screen or something, but since we're working in shaders, it's a little bit harder to print out information from shaders other than literally putting pixels on the screen. So you'll just have to either experiment with that for yourself or take my word for it. Let's see. I can undo all of this. Can't I? And leave that alone. All right. I'm done here. This has been macros and shaders. You can have fun with this. Most of the information that I said in this video is something that probably won't actually be useful to most of you in the real world, but you never know. It's fun to learn about this stuff, I think. So, let's see. Let me, did I spell that right? I-A-L. Yeah, I think I spelled that right. Let me push that commit. If you want this code, link in the video description to a GitHub repository. I have a Patreon, so if you want to contribute towards these videos being made, there will be links to that in all the usual places. Otherwise, I try to post a couple of these videos a week. One tutorial, one let's make a game tutorial thing. Sometimes I'll post more than that. Today, I will probably be posting 2 videos, this and the function one. So if you want to see more of that, definitely subscribe. I hope you all found that interesting, and I will see you all later. Special thanks to Emily Koyo, Posho, Edward Holt, and Zenith for supporting these videos. If you want your name in the credits or to hear yourself shouted out at the end, head on over to the Patreon page in the video description to join the fun.